Hello class, in this video we're going to be looking at applications of parabolas. The learning intention of this video is for us to be able to set up a quadratic equation to model real-world problems, to know how to apply the processes of quadratics to identify key features of a graph and relate them to real-life context, and lastly to be able to identify the possible values of a variable in a given context. Most of the application questions that you're going to be dealing with is going to involve either going to be looking at bridges where you're going to be modeling an equation that represents like the cable that supports a bridge, or oftentimes you're going to be looking at equations that represent like objects being thrown into the air. So that's what projectile motion is going to be about. When we're going to be solving or dealing with application questions, some of the questions they may encounter may involve you to actually define variables. So what that means is you need to be able to understand and interpret what each letter or each variable represents in the word problem. So in this case over here, I've got the equation given to us. So in this case, you need to understand that the letter H in this case represents the height above the ground for the javelin to be thrown in the air. And the letter D in this case is going to represent the distance that's being thrown away from the actual athlete itself. The thing you might also be doing is you might be forming equations. Now, most of the time, about like 80% of the time, you're going to be given the equations already that represents or models a particular scenario. So in this case over here, it's already given to us. But some other times you might need to actually construct an equation itself. And these equations over here, they're not too complex because most of the time they will ask you to actually find the perimeter as well as an area of a rectangle or square, which is in this case is going to be length times width for the area, okay? You will be required to solve it. So when you're solving it, you're going to be using either the quadratic formula when it's represented in the standard form, so that's what represented by this table, or if it's represented in the turning point form, then you're going to need to use square roots in order to solve for x in this case. 4 says deciding on a suitable range of values of the variables. Now, this is really important because in this case over here, you guys are probably aware that when you are solving for x-intercepts, sometimes you might get 2 x-intercepts, but in this case over here, when you deal with an application questions, usually there's going to be one of the x-intercepts that doesn't actually make any sense at all for that particular problem. And it's generally going to be the negative value. So I'll give you one example to show you what I mean by this. So notice over here, I've got an equation that models, like, for instance, the projectile motion of this basketball going into this particular basketball hoop over here. In this case over here, if you were to solve for x, you're going to get 2 x-intercept values. However, if the question was asking you how far did the ball land from the user, it doesn't actually make any sense that your value of here is going to apply to that particular situation. You can't have a negative distance to get over here because in this case, the person is actually throwing in front, not behind them. So in this case, that's why I said the negative solution won't make sense most of the time for application type of questions. 5, you're always going to be getting a question that will ask you to actually sketch the graph showing key features. So in this case, you need to show like the turning point, x and y intercepts, but sometimes they might actually give you a domain as well. And a domain is pretty much like a restriction or a range that shows all possible x values. So in this case over here, that is what the domain looks like. So if you're going to be sketching this particular graph, you're trying to only draw it from 0 to 40. Usually when you're drawing it, this is how you might draw it, but because it's given you a domain, you don't want to show any values that's less than 0 or any values that's greater than 40. Hence, if I also draw it, then this is what my graph here would look like. Notice over here, I'm not drawing beyond beyond 0, and I'm not drawing beyond 40 as well. So that's how you should be drawing it if they were giving you a domain. And lastly, you need to actually identify what is the maximum or minimum turning point. So when questions ask you to find the minimum or maximum, then you need to be able to identify the asking essentially for the turning point, okay? And you also need to be able to understand what the turning point represents in the scenario. So for instance, over here, if the question was asking what is the maximum height, this is essentially asking you for the y value of the turning point. I'm now going to go through 3 examples in total so you have a better understanding of how you can actually solve application questions related to quadratics. So this particular question over here reads a ball is thrown upwards, okay, and they've given you an equation over here. First part, just want you to sketch it. So if you're sketching this over here, just notice in this case, you have an equation that's expressed in the standard forms, and because it's expressed in the standard form, the value of c is going to give you what your y-intercept. So in this case, your y-intercept is going to be 0, 0. So that's going to be pretty easy. Let's now find out what is your x-intercept in this case. Now, usually I would recommend using the quadratic formula, but if you're looking at this equation over here, you can readily factorize this, and because you can factorize and then use null factor law, I'll rather you use that approach instead. So in this case, I'm going to sub h is equal to 0 to solve for my x, or in t in this case over here. So in this case, once I've done that, I'm going to factorize it, take out the highest common factor, which is going to be negative 5t, and then I'll use a null factor law. So therefore, if I do this, then t is going to equal to either 0 or 4, and now I'm going to find out what is my turning point. So in this case, I'll just substitute it into this formula over here. So b is going to be 20, so substitute that in, along with negative 5, you simplify that, and you're going to get a turning point x value that corresponds to 2. Fine, substitute that into the original equation, solve for the y value, and if you do that, then you should get a value that's equal to 20, and hence your turning point is going to be 2, 20. Now that we have found out all the key features of our parabola, let's now sketch it, okay? So what I'm going to do first is I'm going to just firstly choose an appropriate scale. So these are the scales I'm going to be choosing for my x and y axis, and then I'm just going to be plotting the coordinates into my Cartesian plane and draw a curve to represent this. Notice over here again that they've given you the domain over here, so 0 to 4. So you don't want to draw anything that's beyond this particular range over here, okay? And generally speaking, when they give you this, usually the last value of the domain is always going to correspond to the x-intercepts most of the time for year 10, okay? So that's just a little heads up over here. Now, since we've done part A, let's now answer part B. So the part B reads, what maximum height does the ball reach? So essentially it's referring to the turning point, but to be more exact, it's referring to the y value of the turning point, because that corresponds to the height. So in this case, your answer is going to be 20 meters, and you would ideally want to answer this as a worded sentence. And for part C, how long does it take for the ball to return to the ground? So in this case over here, that's when the height is 0. So you have two answers, but remember, you want to choose the one that's most sensible in this case. The most sensible answer is going to be this one over here. So therefore, your answer is going to be 4 seconds, okay? And make sure you are using the appropriate units in your final answer as well. In our second example, this is a very similar example as the first one, so it's another projectile question, and this time you're throwing a javelin. First part also wants you to sketch the graph, so let's find out all the key features. Because our equation is already expressed in the turning point form, we can already identify what our turning point is going to be. Let's next find out what our y-intercept value is going to be. So to do that, we'll just substitute x or d is equal to 0, and therefore simplify the equation. If you do this, then you're going to get a y-intercept value that's going to equal to 11 on 4, but I always try to put it as a decimal so that you can actually plot this later on to your graph, okay? Once we've done this, then let's find out what our x-intercept value is, or what is our d value in this case, by substituting h is equal to 0. So when we do that, then this is what you should get. What we're going to do is, because since we're trying to solve for d, I'm going to move 9 to the other side. So I'll subtract both sides by 9. And then what I'll do is I'm going to remove that negative 1 on 16 by multiplying both sides by 16. And if you do that, then this is what you should get. Now, because you can readily get this as a perfect square, we're going to get rid of the squared sign by taking the square root of both sides, okay? And if you do that, then remember you're going to have a positive answer as well as a negative answer. And then what you need to do now is just move 10 to the other sides by adding 10, and therefore you're going to get a x-intercept value that's going to equal to negative 2 as well as positive 22. Once we found out all the key features, now we're ready to actually plot this onto our graph. So therefore, firstly, identify what's an appropriate x scale as well as a y scale. And once I've done that, I'm just going to plot these values in and therefore draw a parabola that connects all these 3 dots over here. Once I've finished doing part A, we can now answer part B, part C. So part B, again, is asking for the maximum height. So again, it's asking for the y value of the turning point. So your answer is going to be 9 meters in this case. That over there, I just copy and paste. That should be 9. And for part C, what horizontal distance does a javelin travel? So in this case over here, it's asking again for the x-intercept. So your answer is going to be 22 meters, okay? Now, what I want you to do now is, by referring to these two examples, I want you to now answer this question over here. Give yourself 5 minutes, and then we'll go through the answers together. So for the first part over here, you need to find out what is your x-intercept, your y-intercept, and your turning point. So in this case, your y-intercept is going to be 0, 3, because that's most obvious since it's already in the standard form. We'll now find out what your x-intercept is, and this time I'm going to be using the quadratic formula. So once I use the quadratic formula, substitute your values of a, b, c into the formula and simplify that. In this case, if you the square root of 256 is going to give you to 16. So, and again, you're going to have two versions, the positive as well as the negative version. Simplify what this is going to be, and this is going to be your x-intercept values. We'll now find out what our turning point value is by using the formula negative b on 2a. Substitute the values in, and you should get an x value that's equal to 1.4. Substitute that back into the original equation to find out what the y value is, and you will get an answer of 12.8. Hence, write your turning point as a pair of coordinates. And now that we've found out all the key features, we should be able to graph it. So this is what your graph should now look like. And to answer part B, the answer part B is going to be 12.8 meters because that's the y value of the turning point. And again, I need to include this over here. And for part C, how long does it take for the ball to hit the ground? In this case, that's going to correspond to 3 seconds, okay? So that's how you'd answer this question. Now that we've gone through several examples that were related to projectile motion, I want you to please have a go with answering questions 3, questions 6, 7, as well as questions 8 and 9. Please give yourself 20 minutes, so please pause the video right now. I don't really recommend for you guys to continue to watch the video because I need you guys to get much practice with these questions over here, because if you can't do these, the examples maybe that I'm going to show you afterwards might not make as much sense. So try to give yourself 20 minutes to answer as much questions as you can before moving on. In the very last example that I'm going to show you today, this is very different from all the other examples that you've looked at previously because this does not involve projectile motion. Instead, this particular question over here doesn't actually give you any equation at all, and you need to actually construct this, and it's related to like finding the perimeter and area. So let's read the question together. It says a piece of wire measuring 100 centimeters in length is bent into the shape of a rectangle. Let x be the width of the rectangle. So generally speaking, this is how you would actually label the sides of a rectangle. And we know that when you're trying to find the perimeter, because part A wants you to find the perimeter, it's going to be the double of your length plus double of the width. We know that the width in this case is going to be x, so let's substitute that in. So if I was to rewrite the equation for my perimeter, it's going to be 2l plus 2x is equal to 100, because what I've done is I've substituted w as x, and we've already been given what the perimeter is. Perimeter is going to be 100 centimeters in this case. Now, because the first part of the question wants you to solve for L, meaning that you need to write an equation where L is the subject, we're now going to rearrange this question over here to make L isolated. So what I'll do is I want to move 2x to the other side and divide both sides by 2. Hence, this is going to be equation for the length for your rectangle over here. Once I've done that, then I've finished answering part A. We'll now answer part B. Part B wants you to find the area of a rectangle. So generally speaking, we know that the area is going to be length times width. And in this case, your width is x. So, and since we've already found out what L is equal to, we're going to substitute that into our equation as well. So this is what you now get. So if you expand that, then this is going to be the equation for the area of the rectangle. So we've now finished answering part B. What I'm going to do is I'm going to intentionally skip part C because this might not make sense for you now. I'll actually answer part D, and once I've answered part D and sketched it, you might be able to answer part C successfully. So in order to answer part D, I'm now going to find out what is your x-intercept by substituting y, or a in this case, is equal to 0. So if you do that, then this is your equation over here. To solve for x, what we're going to do is we're going to factorize it by taking the highest common factor out and then use the null factor law. And if you do that, then you're going to get an answer of 0 or 50. So that's going to be your value of your x-intercepts. Once you've done that, then you should be able to graph this by then for finding your y-intercept and then your turning point. So your y-intercept, we already know is going to be 0 because that's the value of c, okay? Your turning point can be found by using this formula. Substitute the values in. Your x value turning point is 25. Substitute that into the original equation to find the y value, and this is going to be your turning point. Hence, when you graph this, then this is going to be your final answer here. So we've now answered part D. Now that we've answered part D, I'm going to go back again to answer part C, because part C is asking you to decide on the suitable values of x. What that question is essentially asking is, give me possible values for the width of the rectangle, okay? And to answer that question, that's pretty much when the x value is not equal to 0 or not equal to 50, because at these particular widths over here, notice that you're going to get an area of 0 and you're not going to get any shape, whether it's going to be a rectangle, square, triangle, if your area for that particular thing is going to be equal to 0 for the width. So that's the reason why to answer this question, your answer is going to be any value between 0 and 50, but those two values are not included. That's how you write the answer for this particular question over here. We can therefore answer part E. So to use the graph to determine the maximum error, so that's the y value in this case of here, so it's going to be 1,875 centimeters squared. And finally, for part F, what will be the dimensions of the rectangle to achieve its maximum area? We already know that in this case here, for the maximum area, that's when the width is going to equal to 25. So therefore, to find out the dimensions, which is the length as well as width, we need to find out what our length is. So in this case, remember, we already found out the equation for length. That was 50 minus x. So if we substitute x being a width into the equation, that will therefore give you a length of 25. Hence, the maximum dimension in this case over here is going to be 25 by 25, okay? What I want you to do now is I want you to please answer this question over here by referring to the example that I've just looked at. So give yourself 5 minutes and then we'll go through the answers together. For part A, again, you're going to need to find out the perimeter that will relate its length, in this case over here, in terms of x. So in this case over here, again, W is going to be equal to x, and we know that the perimeter in this case is equal to 80. What we'll do now is we're going to solve for L by moving 2x to the other side, and then divide both sides by 2. Hence, this is going to be the equation for the length. For part B now, you're trying to write an equation for the area. So in this case, your area is going to be length times width. Substitute all the things you know in. So hence, this is going to be the equation for area. We're now going to, again, skip part C because it's a bit more easier to do part C once you've done part D. So what I want to do is I want to find out what the x-intercept value is going to be by substituting A or Y is equal to 0. Well, again, we're going to factorize this because you can easily find a highest common factor and then use a null factor law. Hence, your x-intercept is going to be equal to 0 as well as 40. Once I've done this, then I'm going to find out what is my y-intercept. In this case, it's going to be equal to 0 again. And then I'll find a turning point by using this formula. So hence, you should be able to get a turning point value that's equal to 20 and 1,200. So what I'll do now is plot these three coordinates into my Cartesian plane and draw a curve that connects them all. Once I've done this, I've therefore answered part D. We can therefore go back to answer part C. So in this case, it's asking decide on all suitable values of x or all suitable values for the width. And again, that's when your width does not give you an area that equals to 0. Okay, so in this case over here, your answer is going to be any number between 0 and 40, but 0 and 40 are not included. To answer part E, that's going to be essentially the y value of the turning point, so it's going to be 1,200. And for part F, the dimensions of the width is going to be equal to 20 to give you the maximum area. So again, substitute that into the length formula to find out what the length is going to be. In this case, this will also be equal to 20. So your maximum dimension is going to be 20 by 20. What I want you to do now is I want you to please answer these questions over here. This is pretty much the end of the video. Hopefully you're able to meet the success criteria of today's video. I'll see you guys again in the next video. Bye.